down. Let's do that. Okay. All right. In this video, we've seen already that there's several possible scenarios when you're solving a system of two equations and two unknowns. You might have one solution. In that case, we say the system is consistent. On the other hand, for a different system of two equations and two unknowns, you might have no solutions. And in that case, we say that the system of equations is inconsistent. The third scenario that we've seen is where you have a system of two equations and two unknowns for which there are infinitely many solutions. This is also an example of a system of equations that is consistent. What I want to demonstrate is, what does this mean from a geometric point of view? And so if I go to my graphing calculator, I'm going to treat the x1 as an x-coordinate and the x2 as your usual y-coordinate when graphing on the plane. So what I have here is a negative 3x plus 2y equaling 1. And that's an equation that we get. So the equation corresponds to that line. And then the second equation is where I have 5x plus y equaling negative 4. And so the second equation corresponds to this blue line. And the system of equations, the solution to the system of equations corresponds to the intersection of these two lines. Now the intersection of these two lines would correspond to an x-coordinate of negative 9/13. So you can verify this with a handheld calculator that negative 9 divided by 13 should be about negative 0.692. And likewise, a y-coordinate, or x2, equaling negative 7/13 corresponds to a y-coordinate of negative 0.538. And so when you have a consistent solution with one solution, it corresponds to that single point where the two lines intersect. Now compare that to a system of equations that is inconsistent. In this case, this is an example where we get 6x minus 10y equaling 0, and where negative 3x plus 5y equals 8. And in this particular case, as I search for the intersection between these two lines, these are in fact parallel lines which never intersect. And that corresponds with what it means to have an inconsistent system of equations. It means that the lines corresponding to each equation never intersect. Last but not least, what does it mean when I have a system of equations that has infinitely many solutions? Well, in this particular case, if I have a 4 here and a 10 there equaling 14, with a negative 6x minus 15y equaling negative 21. What you see in this case is that the two lines are overlapping each other. You can barely tell, but if I turn off the blue line, the second equation, you can see that the red equation was just behind it. And so when there's infinitely many solutions, that's when we have a consistent system of equations. It corresponds to having two lines that are overlapping right on top of each other. Now in general, you can actually have a system of 3 equations and 3 unknowns or variables. In this case, to have a so in this case we can revisit what it means to have a consistent system or an inconsistent system. But notice that if each equation has 3 variables, then the graph with x, y, and z axes, each equation is a plane. And so these ideas that we're practicing and exploring are going to translate into higher dimensions, even beyond the 3rd dimension. And so try to pay attention to those general patterns that would translate even to higher dimensions.